Hello everyone. Today we will be talking about the LiDAR technology. So let's discuss LiDAR in brief. In this presentation, I will be talking about a brief introduction to LiDAR, its importance, the working components, its working principle, and majorly we will discuss the applications of LiDAR in computer vision field. So what is LiDAR? It stands for light detection and ranging or image or light imaging detection and ranging. From the name itself here you can make out that it's something that detects the range and object with the help of light. It is similar to the laser system, but here we use the laser lights instead of radio waves. LiDAR is generally used for different applications like agriculture monitoring and generating maps, etc., which we will discuss in the later portion of this presentation. It is an active remote sensing technology that measures the distance by illuminating a target with a laser and analyzing the reflected light. So here first of all it is an active remote sensing technology. So what does this active remote sensing means? It does not require an external power source for its operation. There are two types of sensors, that are active and passive sensors, but here the active sensors are the ones that do not require an external power source for operation. They carry their own power source along with them and it's operational. So here the sensor will generate or throw light on whatever object it has to detect, and then when the reflected light comes it will analyze the distance or the chemical properties according to the way it is designed to detect. By illuminating the target using laser beam, a 3D point cloud of the target and its surrounding can be generated. Here the LiDAR technology generates a 3D view of the object. It not only just detects the object, it generates a 3D view which gives more precision and clarity. Now, three types of information can be obtained from this LiDAR, that is the range, the distance with which we are measuring. It is specially used in topographic image generation. The chemical properties, for example, we have to detect the quality of soil or air, and then we have velocity of the target. Now, why LiDAR? First of all, as I mentioned, that it's an active sensor. So power source is not required, and even because power source is not required, it is not a condition that only when sunlight is there the object is operational. It can be used in night time as well. It has high resolution, so we can generate high resolution maps because of that, and it is a coherent source of laser produces coherent source. Now the components of LiDAR. We will discuss this in very short, that is frequency, wavelength, LiDAR transceiver, the scanner, the POS, operator, data storage and computer. So these are just the wavelengths in which it's operational, which is infrared, near infrared, blue green. The LiDAR transceiver, it that generates the laser beam that is given to the object. The scanner, now the scanner has three subcomponents: the optochemical scanner, the ranging unit and the control processing unit. The scanner which just scans the area through which it passes. The POS, it measures the sensor position and orientation. We will discuss this in the applications part. The operator, it permits the operator interaction with the system. Now the laser and this computer system needs to interact. So the operator works as a bridge between the computer and the sensor. And when this information is collected, we need a data storage. So that is the data storage part of the LiDAR system. The working principle, see here you can see that we have the transmitter and the receiver. Now the transmitter will throw this laser on an object. Now that object will reflect the light that will be received by the detector. And then we have a system control and data acquisition, which will transmit the laser and then even receive it, and then it will pass this information for the data analysis and interpretation part. So this is a very brief working structure of a radar system. Now let's discuss this in brief and in detail as well. The application: autonomous vehicles. We all have heard about the driverless cars these days. So how the driverless cars detect the 3D objects? LiDAR helps in that. LiDAR systems work by measuring the object's distance relative to the self-driving vehicle's position to create a 3D replica of the environment. See, in the image you can see the kind of 3D replica that is generated. An integrated computer system measures the time between the initial laser pulse and the receiver pulse using the speed of light to compute the distance the light has traveled. So when it receives the laser back, it computes the distance from the object using the speed, distance and time formula. It generates a 3D replica of the environment, which is a very major application. It uses these data points to form a point cloud and create 3D models of the objects and its surrounding. Now, when the objects are detected by the LiDAR, it then identifies that what object it is, and according to that, the vehicle is already pre-designed to act. For example, if the LiDAR detects a pedestrian, then the vehicle is already designed that if a pedestrian is detected, the car needs to stop. So likewise, the behavior is determined by the objects that are designed by the LiDAR system. For aerial inspection, now there are certain areas which are very difficult and remote to detect. So the aerial inspection is done with the help of a LiDAR. The agriculture. Now see, as I said, it also helps in detecting the chemical properties. Now the satellites have the LiDAR sensors in them. So whenever an area is detected, or the satellite or even the small machines that run on the farms have LiDAR systems that can help to identify the quality of soil or to optimize how much water to give, the herbicides, the fertilizers, the pest control. All of it can be detected with the help of LiDAR. In the first image here down, you can see that there is a small machine which is running on the farm that will detect the chemical properties of the soil. The surveying and mapping. Now this is a very crucial part, that very accurately it detects all the objects that comes in its path. Here in the second image you can see that an airplane has, or a drone, whatever, has an LiDAR sensor that is scanning the entire area. So whenever this collected information we have, we can generate the maps very accurately for further use. And then we have the renewable energy. LiDAR can identify the requirements for harnessing solar and wind energy, such as optimal solar panel positioning. It can calculate direction and wind speed to allow the operators of wind farms to build and place tribunes. Now, it also helps us to identify that which positions of the solar panels or the wind systems can help us to maximize the energy which we generate and collect. So these are the applications of the LiDAR technology in the field of computer vision. It generates the better positioning images, like which positions of image of the solar panels or the wind systems can give more energy. The maps can be generated, the soils can be detected, and a 3D view for autonomous objects can be generated. So yes, that's it from my end. Thank you.